All right, so if section 1.1 was something you've done before, number 1.2 is going to be some of this is going to be stuff you really haven't talked about before. So be sure you watch this video. We're talking here about the properties of real numbers. Well, the first thing we need to do is define what is a real number. Well, all real numbers can be classified as either a rational or an irrational number. The set of rational numbers includes several different subsets, including natural numbers, whole numbers, and integers. Well, we need to know exactly what are all these things and how can you classify numbers under these different categories. Well, it works like this. We have all of these different types of real numbers. So we have these different little symbols we like to use as shorthand in math. So for the real numbers, we're going to use an R. So we have all these different real numbers. There are such things as non-real numbers. We're going to talk about those a little bit later in the semester. But for right now, we're talking about real numbers. If you have a real number, it can be one of two things. It is either a rational number. A rational number is a number that can be written as a ratio, or it's an irrational number. Irrational numbers, and they have a little bit of definition here. Irrational numbers are non-terminating, or non-ending, non-repeating decimals. So for example, one irrational number that you know is pi. When does pi end? It's 3.14, blah, 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 and it keeps on going. It doesn't ever end, so it's an irrational number. Another example of an irrational number is a square root number that doesn't end. For example, the square root of 2. I cannot write the square root of 2 as a ratio. For example, on your calculator, if you took the square root of 2, you know your calculator will turn any decimal into a fraction. If you hit math, enter, enter. Well, this one's not going to change it because it's not possible to change to a fraction because it's irrational. Rational numbers, like I said, are numbers that can be written in a ratio form or a fractional form. So example, 1/2 is a rational number. 2 is also an irrational number because it's the same thing as 2 over 1. What about like 0.4? Well, 0.4 is also a rational number because that's the same thing as 4 over 10, which is the same thing as 2 over 5. So those are different rational numbers. So you can either, real numbers, they're either rational or they're irrational. If they're rational, there's a couple other things that they could also be. For example, it could also be an integer. Integers are what I like to call your counting numbers. So usually you would say a whole number. They're not decimals. But there is a category called whole numbers. So I don't like to say whole numbers. I like to say they're counting numbers. If it is an integer, it might also be a whole number. Whole numbers are all your positive counting numbers. And then the only difference between whole numbers and natural numbers is the number 0. 0 is not a natural number, but it is a whole number. Otherwise, they're the exact same set of numbers. So using this bit of information, you could also go ahead and look at this. You might want to copy this into your notes or something. It's basically the same little diagram I just drew, but it actually has the words written out instead of just the little symbols. So we're going to actually classify some of these numbers here on our notes. So the first thing you want to do is identify, are these real numbers? Well, you don't know what an imaginary number is yet. So yes, they're all real numbers. I'm going to put an R next to every single one of them. After you decide if they're real numbers, and they are, you have to figure out, are they rational or irrational? Well, to do that, there are several of these that you might want to simplify just a little bit. So let's kind of look at them one at a time. 6 over 7, can I reduce that? No. Can it be written as a ratio? Yes, it can, because it is a ratio, so I can put a Q. What about the negative square root of 81? Well, it has a square root in it, so it must be irrational, correct? No, because you know what the square root of 81, it's 9. So this is the same thing as negative 9. Can that be written as a ratio? Yes. So I'm going to put a Q for that one also. 0, can that be written as a ratio? Yes, it's already simplified. What about this one? Could this be written as a ratio? Sure. Technically, it's this over this. Now that's an annoying ratio, but it can be written as a ratio. What about 73? Also a ratio. 34.5 could be written as a ratio. Square root of 36 over 9. What is the square root of 36? 6 over 9, which again reduces, but can be written as a ratio. 26.1 can be written as a ratio. Pi, we've already identified pi. Pi is not a rational number, so I'm going to put the I for irrational. 15 over 3 can be written as a ratio, but I highly recommend you go ahead and reduce that. What is 15 divided by 3? That's just 5. Negative 4.17 repeated. Can you write that as a ratio? Well, if you look up here, irrational numbers are non-repeating decimals. If this is a repeated decimal, then it must not be an irrational number. I can write it as a ratio, so it's also rational. 25, square root of 25, again, reduce that. 5 over 2, ratio. Negative 1, rational. Square root of 42. Again, if you're not sure, you might could use your calculator to check that. Square root of 42, can you simplify that? Here's the decimal. If you're in doubt, you can check it. Math enter. Won't change it because it's an irrational number. Negative 11.2 also could be written as a ratio. Negative 8 over 13 is already a ratio. Square root of 5 over 2. Square root of 5 is another number. I do not know the square root of 5. This one's irrational. 33.3 repeated is a ratio. 894,000 could be written as a ratio. And negative 0.02 also rational. So looking back, we only had a few that were irrational numbers. I'm going to go ahead and just kind of mark those for myself. If it's an irrational number, you're done. You can't check it for anything else. That's all it is, real and irrational. But on all of our rational numbers, we need to go back and look, well, is it also an integer or a counting number? Well, 6 over 7 is not a counting number. No one says that as a counting number. So this one is also done. Negative 9 is a counting number, so it is also an integer. 0 is a counting number, also an integer. This one's a decimal. That's not a counting number. Counting number. Not a counting number. Not a counting number. Not a counting number. 5. That would have been tricky if you hadn't reduced it. 5 is a counting number. Decimals are not counting numbers. Fractions that can't reduce are not counting numbers. Integer. Not an integer. Not an integer. Integer. Not an integer. So we keep narrowing it down to just a few more things that we can look at. So if it is an integer, is it also a whole number? Well, what's the difference between integers and whole numbers is that whole numbers are not negative. So I need to go back and look at all the ones I classified as integers by writing a Z. Is that a negative number? Yes, then it's not a whole number. Is 0 a whole number? Yes, it is. Is 73 a whole number? To be a whole number, it has to be positive. 73 is positive. Is 5 a whole number? Yes, it is. Is negative 1 a whole number? No, because it's negative. Is 894,000 a whole number? Yes, it is. If it's a whole number, is it also a natural number? Well, what's the only difference between whole numbers and natural numbers is that number 0. So every one of these that I marked as a whole number, I can also mark as a natural number except for 0. So this one is not natural, but this one's going to be natural, this one's going to be natural, and this one's going to be natural. So that's how we classify numbers. Second part of this set of notes is back to stuff that you've kind of done before. It may be a while since you've talked about actually what your properties are, but we have a couple of different properties of real numbers that's going to be true all the time. You have your commutative property, which means if you rearrange it, you're still going to get the same answer. 2 plus 3 is 5. 3 plus 2 is also 5. You have your associative, which talks about the order you do your operation in. You have the identity, which is different depending on if you're talking about addition or multiplication. The inverse, which is how do you undo something. And then you have like your closure, which is just that if A and B are both real numbers, then A plus B is also a real number. Or if A and B are both real numbers, then A times B is a real number. Again, you don't know what an imaginary is yet, so it doesn't really matter. But distributive is another big one that you should be very familiar with. So let's just look at simplifying some of these expressions. Question number 1, what's the very first thing you're going to tell me you need to do here is to distribute. So I'm going to distribute the 8 through all that. That's 24A minus 8B. I'm going to distribute the 4 through all this. That's going to be 8B minus 4A. When I combine my like terms, 24A minus 4A is 20A. Negative 8B plus 8B, those are going to cancel out, so 20A is my final answer. Same thing on question number 2. Combine your like terms. There's nothing I can simplify beforehand, so I'm going to add 40R to 11R, 51R. And then I'm going to add 18T to negative 5T. That's going to be plus a 13T. And I can't simplify that any further. Question number 3. What do we need to do first here? Well, there's actually a couple things you can do first. You could distribute first if you wanted to. But looking at this, I could actually simplify inside my parentheses first. And if you can do that, you really should, because it's going to make it a little bit easier to begin with. So here I have a 4J minus a 6J. Well, that's negative 2J. And then I have a 2K plus 3K. That's a plus 5K. I'm going to put that back inside parentheses with a 1/5 out in front. I then distribute the 1/5 through this equation. That's a negative 2/5 J plus 5/5 K. What is 5/5 K? Well, that's just K. So this is negative 2/5 J plus K, and that's going to be your final answer. Question number 4 is a good question. I can't simplify the inside to start with, so I am going to need to distribute. So this times this. How do you multiply fractions? Well, first thing I'm going to do is I'm going to put that 12 over 1. So I'm going to do 12 over 1 times A over 3. Tops multiply together, bottoms multiply together. So that's 12A over 3. And then same thing with the B over 4. So 12 times B is 12B over 1 times 4 is 4. Keep the minus sign in between. And then I can simplify both of these fractions. 12A over 3 is just 4A. 12B over 4 is just 3B. And that's going to be your final answer. I'll let you work this one out on your own. You're going to need to distribute the 8. And then, this is the tricky part here, is people often forget when you distribute here to take that negative sign with you. So you're not just going to distribute the 6, you have to distribute a negative 6. You can work that one out on your own with those decimals. Feel free to use your calculator. I'll write your final answer down here. You can use that to check your work. Question number 6, I'll go ahead and walk you through this one. Same thing, distribute the 4. 4 times 20 is 80. 4 times 4 is 16. I'm also, again, going to need to distribute the negative 3/4. So negative 3/4 and negative 3/4. Again, I'm going to put these over 1 to kind of help me with multiplying my fractions. Negative 3 over 4 times 4 over 1. 3 times 4 is 12. 4 times 1 is 4. 12 over 4 is 3. Or if you remember your fraction properties, you can just cancel those out and just say, well, that's going to be a negative 3. Negative 3/4 times negative 16, P over 1. Again, same thing. You can do 3 times 16, 4 times 1, and reduce it. But it's much easier if you just see that I can cancel this out to be a 4. Negative 3 times negative 4 is a positive 12P. After that, I can combine like terms. 80 minus 3, 77. Negative 16P plus 12P is a minus 4P. And that's your